Hello, this is a third in a series of videos that I'm doing regarding visual phasing and actual phasing in the general case. This video, I probably am going to split it into two parts because it's kind of long, but we're going to look at a complex workflow. And it's one that may be familiar to a lot of people doing visual phasing. It's the three-sibling workflow. And I'm going to show you how you can use a slightly modified workflow to actually create ancestor kits for the four grandparents from a visual phasing project using my tools. So this is the three-sibling problem. For input, we have three siblings, sibling 1, 2, and 3, who took factory DNA kits from the major testing companies. And what the output, or the desired output, would be 2 stereo kits for the father and mother, and 4 grandparent kits. They'd be mono kits for each of the grandparents of the 3 siblings. Okay, so this slide should look a little bit familiar if you've watched the previous videos. This is just a slightly altered version of the last slide in my presentation on actual DNA phasing in the general case. And by general case, and what we're going to be doing today is phasing the general case. I mean, we're not going to be parent-child phasing. We are going to be phasing siblings. They're going to be full siblings. We're going to be phasing against one another. Okay, so what we're going to do, it says do not discard or forget to generate. Let's make that active. We are going to generate all of the possible output files, 3 for each sibling comparison for our 3 siblings. That's going to result in 9 pseudo-sibling kits. And if you recall, by pseudo-siblings, I mean they will behave like siblings pretty much to our 3 siblings. However, none of these pseudo-siblings have ever walked the earth. They're not real people. They are artificial synthetic DNA kits, and they will behave like siblings, but they do not represent actual people. Although they are phased kits, that does not mean that they are paternally or maternally phased kits. These are going to be phased at the block level. So we'll get if it sounds like a lot, this is going to make a lot more sense as we go through it because I'm actually going to do it, and we can talk about each step in great detail. But I just want to give a little idea of what we're going to be doing. That way, there's some sort of understanding of the process. So we're going to create these 9 pseudo siblings, which are not really siblings, but they'll act like siblings, but they will be phased. However, they will not be paternally or maternally phased. They will be phased at the block level, having giant blocks of DNA alternating between paternal and maternal within any single file. And we're going to essentially be rearranging those into a useful form and dividing those blocks by grandparent. And that's the visual phasing that we're going to do. All right, step 2. So there are some important considerations when it comes to phasing siblings, or specifically phasing full siblings, that we're going to have to deal with. That are pretty much unique to the issue of phasing full siblings. So what we end up happening, or what we end up getting when we phase 2 siblings, are kits with 3 different types of regions. These regions are called NIR, HIR, and FIR. If you're not familiar with those, NIR are regions where the siblings don't match each other at all. If you did a GED match, one-to-one compare, there are portions of the chromosomes where the siblings don't match. Those are called NIR, not identical regions, I think it stands for. Okay, then there are HIR regions, which are half identical regions, because across any span of chromosome, we have 2 copies of each chromosome, and it's possible that a sibling can match on one, but not the other copy. This might happen, for example, if sibling 1 and sibling 2 both inherited DNA from their paternal grandfather, but on the maternal copy of sibling 1 maybe inherited DNA from the maternal grandfather, whereas sibling 2 inherited DNA from the maternal grandmother. And that results in an HIR region, a half identical region. Then we have the fully identical regions, and these are, if you remember the graphical one-to-one comparison on GEDmatch, where a lot of people check to see if they're full or half siblings by whether or not they have these big green bars. Those green regions are the fully identical regions, the FIR, where the siblings will match each other on both copies of the chromosome across a particular span of DNA. And that might occur, for example, let's say both sibling 1 and sibling 2 inherited their paternal copy across the strand from their paternal grandmother, say, and their maternal copy they both got from their maternal grandfather. So they're going to match on both sides. All right, so that's the basic theory you need to know about phasing siblings. So what we're going to do, what is useful for us, is the half identical regions. We can only phase relatives across the parts where they match each other. So the NIR regions are just useless. The HIR regions are going to give us meaningful phase data, whereas the fully identical regions are not going to be useful for creating DNA kits for the grandparents. And there is going to be applications and reconstruction for those regions as well, but that's a different workflow than what we're going to do today. We're going to reconstruct these pseudo-sibling kits over the HIR regions, and that's it for today anyway. Okay, so what we're going to do is we have a different process for selecting the HIR or for selecting out the NIR regions. We're going to use extract segments tool for that, and a separate process we're going to use for the for eliminating the FIR regions. And we're going to create something in DNA Painter for that. We're going to make these do not touch group, and we're just going to not touch them. Okay, then step 3, we're going to perform our visual phasing in DNA Painter, and we're going to use stranger matches, lists of stranger matches to the 9 pseudo-siblings that we generate in GEDmatch. And we're going to use them to assign phase to the blocks and segments identified from the pseudo-sibling data. And it's easier than it sounds. There's a lot of big terminology in there. And again, we're gonna walk through it step by step. So if you understand something, if you haven't watched the 2 previous videos, you probably should. But if there's something you don't understand, we are going to go through it in greater detail. So don't freak out if there's a term you don't understand, or if you're not sure maybe how each step works yet, because you learn better by seeing. And you learn even better by doing, and you can try this stuff at home if you have 3 siblings too. Okay, step 4, we're going to use my extract segments tool to extract segments pertaining each of the 4 grandparents. So what we're going to do is that we're going to assign the phase on a map in DNA Painter, and then we're going to use my tool to extract the data from the raw DNA files of the pseudo-siblings. And we're going to do that by grandparent. We're going to use those visual phasing maps as almost like recipes for reconstruction. We're going to use those to determine which portions of the pseudo-sibling kits to assign to each grandparent. So step 5, we're going to use my Humpty Dumpty tool to take the blocks that correspond to any given grandparent from the different kits and put them back together. So for example, we're going to have 4 grandparents. We're going to have, say, paternal grandfather. We're going to take all of the paternal grandfather parts of pseudo-sibling 1, all the paternal grandfather parts of pseudo-sibling 2 that we had already extracted, all the paternal. We're going to dump them all together and create this composite kit, if you will, for each grandparent. And they're going to be mono kits, 5-step process. Oh wait, I only have 1 sibling. So fortunately, we've had a volunteer offer her DNA for 3 siblings in her family to make this video. And by volunteer, she hasn't actually shared the files with me, but we're going to be working remotely, and I am in the United States and she's in Australia, and we're going to be exchanging information through my software using the script manager. And I'll get into that a little bit more later. All right, so let's take a look at the resources for this project. We have 3 siblings, sibling 1, sibling 2, sibling 3. I'm not giving the names because this is someone else's private data. But sibling 1 is female and tested with Ancestry. That's all you need to know about sibling 1 for now. Sibling 2, female, tested with MyHeritage. Sibling 3 is male and tested with MyHeritage. And that should be enough information on the 3 siblings to get us through step 1, create our 9 pseudo-sibling kits. And we're going to use the ultimate phaser tool and the extract segment tool in this demo. Although as an alternate workflow, we could use the Phoenix and Dark Side, and maybe we'll do that some other day with some other 3 siblings, or maybe we'll do the 4 sibling scenario at some point. Okay, in this project, the first thing we're going to have to do is convert all the factory kits to a common template. What I mean by template is I'm referring to the fact that one of the kits is an ancestry kit and 2 are my heritage kits. We got a couple choices here. We're going to use the Borland Genetics Chameleon Tool. We could make them all effectively ancestry kits, or we can make them all MyHeritage kits, or we can create a combined template that uses all of the SNPs tested by either company, and it's going to be a large file, or we can create some sort of shared template that contains only the SNPs tested by both companies. For this video, we're going to use the third option. We're going to create a combined template. This is going to be a large file, and it's going to make the tools run slower. However, the advantage is it's going to be lossless. And I recommend this template, or using a combined template whenever possible, because it's lossless, unless your computer can't handle it. I'm running a Windows PC. It's a Hewlett-Packard with Intel i5, and it doesn't seem to have any problem with these large templates in most tools. So that's what I'm going to do, and I recommend that you do that unless you've got an old computer that can't handle it. How will you know that your computer can't handle it? You'll start to see a lot of things like Windows is not responding. It won't do any harm to your computer or anything like that. It'll just cause great frustration, and you may want to then, for example, in this project, use all MyHeritage templates. But anyway, we got to convert the kits to a common template. That's what we're going to do. We're going to use the Chameleon tool. Let's do it. Okay, so let's fire up Borland Genetics version 2.1. And it's important to use version 2.1. If you have an older version, please download the new version. There were some glitches that are fixed, but most importantly, version 2.1 has a script manager and script functionality that we're going to be using. And also, it is compatible with the build 37 coordinates that are used as by default in GEDmatch Genesis. Now that classic GEDmatch is frozen. All the kits that we are uploading, these pseudo-siblings, are going to be uploaded to the Genesis side, as all kits from now on will be. Okay, so let's manage DNA resources. Let's get these sibling kits from our data library into our active resource list. So before we do that, actually, let's go back and let's use this script manager. Let's start recording a script. And by recording a script, it's going to record everything we do, and it's going to produce output in the script language that's really pretty easy to understand, so that we can run the script later or edit the script, or in this case, send the script to Australia. Okay, so start recording the script. I'm going to create a name for the script. So let's call it Project 3 Sibling Phasing. Continue. Okay, the script recorder has been enabled, and when you're finished recording, just go back to the script manager to disable. Continue. Okay, so you see down there now, instead of having start recording script, now it says stop recording script beta. So when we want to finish recording our script, we can just go down there and stop recording. Okay, but now back to the main menu. Let's go back to our resource manager and start adding the siblings. Now, remember I said I don't have siblings, and that we're going to use siblings on someone else's computer? Well, what I do have are some ancestry kits and some MyHeritage kits. So I just have some dummy kits that aren't siblings at all, but that's okay, because all I need to do is record the script, and then she can play back the script on her machine with actual siblings. So that's what we're going to do. So I've created 3 files on my computer. 1 is an ancestry and 2 are MyHeritage kits. They're not siblings, but I'm going to pretend they are. Okay, so let's add these resources to our We're starting from scratch with this project, so I'm going to add them to the resource list. Okay, so start with sibling 1, which is ancestry, which their kits are in text format. So it adds it to the list. Okay, and we said that sibling 1 was female. Continue. And it's important that even though these aren't siblings, that I'm using the actual information for the siblings, that I'm keeping track of which one was female, because it's going to be part of the script. And I'll show you that in a minute. Okay, so is there a GED match number? We're not going to use that for now. There is, but for privacy reasons, I'm not going to show you that right now. Continue. All right, so let's add the second one. Let's add sibling 2, which was the MyHeritage female sibling, if you remember. Sibling 2, and that's a CSV file, I think, for MyHeritage. So my program just converts it to a text format, and it actually will save a file called sibling2.txt into the data library if you have a MyHeritage. Okay, so that's female, we said. Continue. We're not going to put a GED match number because this is not my family. Okay, now we're going to add the third sibling. Sibling 3. Again, this is going to be MyHeritage kit, so it's a CSV. It's going to have to automatically convert it to a text file. Doesn't take very long. Then save the copy of that text file to the data library. And then it's got to get some information from the text file. And we're going to say that's male because that's the brother, the third sibling. Okay, is there a GED match? No. Okay, so now looking at our active resource list, we've got sibling 1, sibling 2, and sibling 3. So just to give you an idea how our script manager or script functionality works, let's just take a break from the actual workflow for a minute. Go back to the main menu, and let's go to Manage Scripts. Let's pause the script recording. So I'm going to stop recording the script, select. Okay, the script recorder has been disabled. Script is successfully saved and added to the active script list. Okay. So there, look at that. We've got a script in our list now, Project 3 Sibling Phasing. So let's take a look at what that script looks like. Let's go to View, Edit, and Save Script. Okay. We're going to only have one script to choose from, so let's view this one. What does a Borland genetics script look like? Well, it's pretty simple. The first word or the procedure in the script is going to basically tell you which tool you used. And we'd used the add resource tool 3 times. So it's not surprising. We have 3 lines here. And then it's going to pass parameters. It's going to tell which parameters we passed to each tool. For add resources, it only requires 3 parameters. The name of the kit, which is the file name, but you don't need any extension information or anything like that. It's the corresponds to the name in the resource manager column, if that's helpful. The gender, and we put quotes, single quotes around any kind of string, any string of text, and then NA for not having a GED match number. If we had put GED match numbers in, it would have said something like A1, 2, 3, 4, 5, 6, or I guess in the new GED match Genesis lingo, it would be like AB 1, 2, 3, 4, 5, 6, 7, or whatever actual kit number it was on Genesis. So we're going to continue. It's going to keep that script in memory so that if I continue to record the script now, it'll ask me for the file name. And if I wanted to, I can create a separate sort of fork and create a different file. But it's going to still have that script in memory, and it's going to add on to it unless I choose the clear active script. But I don't want to clear the script. I want to keep going with this particular workflow. But just to let you know, that's what you would have to do if you wanted to start over. You either shut down Borland Genetics entirely, or you could just press that little click clear active script button, and it'll reset the script to nothing, and you'd be starting over with an entirely new script. Okay, so let's go on and let's start recording the script. Okay. And project sibling phasing continued. Okay, it's been enabled. All right, so back to the main menu. Let's start creating those pseudo-siblings. If we go back to our resources, remember we've got 3 siblings in there. So we're going to want to do every permutation of phasing possible. And we're going to do it using the ultimate phaser because it allows us to do it in batch, which is going to make our life a heck of a lot easier. Okay, so back to the main menu, and let us start with the Chameleon tool and combine the templates for this project to create a common denominator template. So Chameleon tool and sibling 1 and sibling 2, if you remember, are on different templates. Sibling 1 is ancestry and sibling 2 is my heritage. So those are the 2 templates we're going to work with that we're going to select for the Chameleon tool. We could have picked sibling 1 and sibling 3, but as long as we picked one ancestry, our only ancestry one here, and our MyHeritage one. Just a note for so people know, in this case it's pretty easy, but sometimes you may have like 3 ancestry kits and you may think, well, okay, I don't need to combine templates. That's not necessarily true because ancestry switch chips, and even so depending on when the ancestry kit was taken, and even within a particular chip being used, whether it's Ancestry version 1 or version 2, they made a couple of changes to their output files from time to time. One of them was to include mitochondrial DNA and things like that. So it'll tell you if you need to combine templates. I already know we do because we're doing 2 different testing companies, but it'll be obvious. It'll warn you and make you convert the templates. Okay, so let's go sibling 1 and sibling 2. Select. The Chameleon tool is running. First, it confirms that they're actually on different templates because, well, it saves time. Okay, so we're going to choose option 3. We're going to map both sibling 1 and sibling 2 onto a custom template consisting of all SNPs found on either template combined. Caution, large file. That's okay. Select. So it's going to start converting the templates. And this actually does take a minute. So what we're going to have when I'm done with this is it's going to be sibling 1 is going to be converted to the combined template. Sibling 2 is going to be converted to this combined template. And sibling 3 we didn't do anything to yet. So that's what we're going to do after this is done. But first, let's wait for the conversion. Not too bad, it's getting faster. It's created a temporary file, that's why it's loading the DNA resource. This is very memory intensive, so it stores some data to disk rather than keeping all in memory so that it doesn't crash or fail to respond. Now it's working on the other kit, presumably converting sibling 2 to the combined template. There may be some parts of this video that I speed up in the interest of time, but this doesn't take too And I'll let you know when I'm speeding it up so you don't wonder why on your computer it takes 5 minutes and on mine it takes 5 seconds. But this is real time when we're operating in. Loading the temporary file created there. Okay, so now we've got to create a new name. So for sibling one text converted to the combined template. So how about we call it sibling one, ancestry version 1. I happen to know it's ancestry version 1. My heritage, they use H and GEDmatch, so let's be consistent. My heritage version 1. I don't know if there were more than one version of my heritage. I'm not sure. I have not tested with that company myself. Okay. So now it's just saving the file to my data library. It's creating a zip file. We're not going to use that zip file because there's no need to actually upload this to GEDmatch or anything. Perhaps in future versions of the program, I can make it run faster by skipping that step unless we ask for it. Sibling 2, ancestry version 1. Or if we're really clever, maybe I can skip the zipping for GEDmatch according to whether the creeper thinks you're going to want it zipped. Okay, sibling 1 and sibling 2 converted to a combined template. Now, let's take a look at our managed DNA resources. And there we go. And notice that sibling 3 is not yet converted. So let's go back to the main menu and let's do the Chameleon Tool one more time. And let's take sibling 3 and one of the kits that are on the correct template. Let's go to sibling 1, AV1, HV1, select, and confirm they're on different templates. We know they are already, but that's okay. All right, so let's map both sibling 1 and sibling 3 onto, no, we only need to map sibling 3 onto the combined template. We don't have to sit around and wait for some sort of, wait for both kits to be converted when one's already on the template that we desire. So we're going to choose map sibling 3 onto the template of sibling 1. Select. So this should run twice as fast because it's only converting one kit. And for the Chameleon tool, it starts off slow and speeds up in terms of going through the kit. Has to do with the way that data is looked up in the kit, in the other kit, in the kit of the desired template. Okay, and you see it's starting to speed up here. We're halfway there. I think this will still create some sort of temp file and then it will have to reload it when it's done. Yep. Then we pick the name and let's be consistent. Let's make it sibling 3 AV1 HV1. Continue. Okay, success. So let's continue and let's go back to our manage DNA resources and make sure that it is actually there. Yes. So now we've got 6 kits where we had 3. We've got the original 3 kits in our active resource list, but we also have the combined template kits for each one of those. So now we are ready to get into the actual phasing itself. And we're going to use the ultimate phaser. But first, let's go back to the script manager. And since this is a new feature, I want to look at it a couple times because it's something you shouldn't be afraid of. It's a very, very useful feature in my opinion. So stop recording the script for a minute and let's take a look. Okay. Let's take a look at the new one. Now we got 2 choices. We'll pick the continued one. And there we go. We've got the original 3 steps where we added the resources to the data library. And you see, now we've got 2 additional steps. We've got the Chameleon GUI, and that just means graphical user interface. My toolkit actually has multiple versions of each tool depending on how they're being used. But anyway, past the parameters to the Chameleon, parameters for the Chameleon, it requires some more parameters. It requires which 2 kits, which mode, and we chose combined, and then what the 2 output file names are. So it's pretty, even though it requires 5 parameters if you're using it in script mode, they're pretty simple parameters. There's nothing really complicated that we're feeding to these scripts. It's just the information that we entered when we ran them. And there's really not much need to write a script from scratch because you could record a script. And if you want to make some changes to it, like you might just change a file name, or you might change female to male or something, or you might change the order of things if there's a problem with your workflow. So, okay. So let's continue and turn that script recording back on. Give it a name. Project 3 Siblings Part 3. And again, it's going to still have those previous steps. So call it Part 3, but it's really all the parts. Continue. Okay, back to main menu. Let's now go to the Ultimate Phaser tool and start phasing. So we want to select 2 related individuals for phasing. We're not doing the special case of the 2-parent phasing. We're doing something different. We're doing a very general phasing of these siblings. Okay, so let's start with sibling 1 and sibling 2. We're going to go through every permutation, and well, we are, but we aren't, and I'll show you what I mean by that. So for sibling 1 and sibling 2, it's going to find out, it needs to know some information about these kids, first of all, to make sure I think that they're eligible for phasing. Okay, so actually it's phased the 2 kits already, but now we've got to select which outputs we want. And remember, we want all possible permutations. So we want sibling 1 and sibling 2, we want sibling 1 x sibling 2, and we want sibling 2 x sibling 1. And that's our first 3 of the 9 pseudo-siblings. And we're going to click select. That's going to just do it for us, executing the ultimate phaser reconstruction script. It shouldn't take too long. Okay, so we're going to enter the file name for sibling 1 and sibling 2. And since I don't feel like cutting and pasting and finding that intersect symbol, I'm just going to call it sib1 and sib2. And I'm not going to put all that nonsense about the format of the kit because there's no ambiguity here. We're not going to create 9 pseudo-siblings in MyHeritage and then make 9 on the combined template. So I don't need to specify any of that. Let's just call it sib1 and sib2. Okay, and it chooses the default gender of female whenever we use the ultimate phaser tool. And that doesn't really matter because the reason it has to pick a gender, and these are not real people. when we use the ultimate phaser tool like this, we're not actually creating real siblings, and they don't really have a gender. They're not real people that never walk the earth. So it just picks female. We could always change that if we wanted to, like if we use this on a parent and child or something. But as a default, it's just going to pick the one with 2 X chromosomes. Okay. Now we've got to pick a name for SIB1 X SIB2. Oh, whoa, fingers on the wrong keys there. It's called SIB1 X SIB2. Continue. Okay, now the third one. And the reason I chose to do the ultimate phaser and extract segments is because it lets you do 3 at a time, and I didn't want to waste your time. You could do Dark Side and Phoenix if you want on your own time. It's probably easier to do, but at the same time, this is faster. So SIB2 X SIB1 is our final for the first 2 siblings compared. Now remember, I'm not using actual siblings here. So the output that it's creating is garbage. Um, so that being said, let's take advantage of that fact, because we don't need to sit around and create these fake pseudo-siblings for garbage kits. What we really want to do is create the script to be run on our friend in Australia's kits. So let's go back to the main menu. And we're not going to do this 6 more times. Instead, let's go to our Manage Scripts. And let's stop recording. Okay. Now we got 3. All right. So let's view the third one. All right, so you see now we've got Phase GUI, it's called. And that's the name of the procedure that's called with the ultimate phaser. That's the actual name of the procedure in the code of the program itself. And the parameters that it passes are the name of the 2 input files, the mode, whether it's AN, BXB, or BXA, and then the output names, with the desired output names of the files. So instead of running it 6 more times, Phase GUI, let's copy, enter, paste, and do it again. Now we're just going to have to make some changes, because now instead of sibling 1 and sibling 2 for the next 3, we're going to want to do, let's do sibling 1, sibling 3. And then instead of doing sibling 1 and sibling 2, let's do sibling 2 and sibling 3, sibling 2 and sibling 3, sibling 3, sibling 2, and we're still going to do each of the 3 modes for each of them, but instead of sib1 and sib2, sibx1, sibx2, sib2, x sib1. Okay, we're going to have different file names. So we're going to want to make this one sib1 and sib3, sib1 x sib3, sib3 x sib1, sib2 and sib3, sib2 x sib3, and sib3 x sib2. And why can I do this? Well, if I wanted to run it on my dummy kits on my computer that aren't really siblings, this is a fully functioning script. It will work. But I'm not concerned with doing that. I don't want to waste my time doing that, because this script is designed to run on someone else's computer, someone who actually has 3 siblings. So I skipped a couple steps there. It benefits everyone. Okay, so let us continue. By the way, someone asks me, before I continue, someone asked me today, can I add comments to this? So, because it can get confusing if you've got a real long script. So yeah, and the symbol we use is the hashtag or pound sign. So let's add a comment at the beginning. First, we add the resources. And anything after that, that pound sign will be considered a comment. It won't actually run. It's just there to make it look nice. Okay, so here we go. Then we create a common template. Then we create a project template, let's call it, and convert all kits to that template. Then we phase. Then we use the ultimate phaser to create 9 pseudo-sibling kits. Okay, and it's okay to put spaces, or at least I think it is. This is a very new feature, and I'm sort of beta testing it as we go. But I programmed it myself, and I don't see why it wouldn't allow you to put blank lines or comments, because that is part of the Python syntax, and this script writing is actually in the language of Python for any computer programmers out there. So if you want to create variables, as long as you don't create the same variable names that are in my program, it's safe to do so. And if you are a Python programmer, you'll know what that means. If not, don't worry about it. We will have some maybe videos on advanced scripts where we create variables and things like that, but we don't need it for this particular workflow. So let's continue. So now it changed, and it knows we changed the script, so it'll ask if we want to replace it or save as, create a new script. We've already got 3. Let's just replace the existing script with the modified script. We don't need to. We're gonna have to make more anyway. So, and if we wanted to edit it, make sure it worked, review it. We pick it from the list, part 3. It got rid of the spaces, but all right. So you can add spaces, and they'll be pretty for a minute, but it'll erase your spaces. But it kept the comments. So, okay, that's good to know. All right. So back to the main menu. Now, well, no, not yet, because we got to start recording the script again. And let's call it Project 3 Siblings Part 4. Okay, and now we're ready for step 2. It's getting late, so I'm being a little quiet here because I have some roommates. We're going to eliminate the NIR and FIR regions because we only want to concern ourselves with HIR regions. Let's start with the easier one. Let's eliminate the NIR regions using the Extract Segments tool. Okay, let's go back to the main menu. Let's go to the Extract Segments tool. All right. Select the kit for which you have mapped your ancestors in DNA Painter. Well, let's start with sibling 1 and sibling 2. Note that there are only three of the 9 pseudo-sibling kits here because we never actually created those other 6. And I'm not going to do that because I don't have the actual sibling files on my computer. Our assistant in Australia is going to do that on her computer. So, but we've got 3 of them on the list. So let's start with the first one, sib1 and sib2. Before we run the tool, we're going to have to do a little prep work on GEDmatch Genesis. I've blocked out the kit numbers just for privacy reasons because this is not my data. And we're going to use build 37 coordinates for this, since that's the default and since that's the coordinates used in MyHeritage and Ancestry kits. No need to do extra work converting now that GEDmatch can produce build 37 numbers. And I'm going to select a threshold of 5 centimorgans for comparison. And we're not lowering the threshold here to see if we can fake a relationship or something like that. We know that these 2 people are siblings. What we're doing is making sure we catch all of the HIR segments between sibling 1 and sibling 2, which I have loaded up here. So let's hit go. And I can't do it live because then you'd see the kit numbers and things like that. So let's go to the next screen, which is the results of the one-to-one comparison on GEDmatch Genesis. Now, if you're used to using the regular GEDmatch as I am, one of the differences in the display here of the output is that you've got data separated by chromosome in the into separate charts, but we're going to be importing this data into DNA Painter, and DNA Painter has already adjusted itself so that it can accept data from Genesis as well as the regular GEDmatch. So let's move on over to DNA Painter and let's create a profile. And here I've created a new profile and I have named the profile Three Siblings Demo. Now I'm going to paste the data from GEDmatch. All right, so here we go. Everything looks nice. It painted. And just to note that I would not call this Three Siblings Demo if this was my own data, but I'm specifically preparing a script and some package files to send to someone else. So what I would do if this was my own data is I would create a profile and call it like Sib1 and Sib2 pseudo-sibling. And then I would create 8 more of these profiles. The next one would be Sib1 X Sib2 pseudo-siblings, and I would use, for that, I would also use the same data from GEDmatch. I would only switch data when I compared different siblings. So for the second set of 3 pseudo-siblings, for 4, 5, and 6, I would use a comparison of Sib1 and Sib3 on GEDmatch and create 3 profiles using that painted data. And DNA Painter makes that really easy because you can clone profiles. But instead, what I've done here is go back to GEDmatch and do sibling 1 and 3 compare, and then compare sibling 2 and 3, and I've put them all in a single profile. I called it Three Siblings Demo. And this itself isn't good enough to send over to Australia yet because we need to have 9 groups. But I am going to extract or export this profile into a CSV, and I'm going to manipulate it further in Excel to create the remaining 6 siblings in a timely manner. Okay, so here is the screen for exporting DNA Painter data. We're going to export it as a CSV, and then I'm going to move over to Excel and show you what I did. So what I did was I changed the group field and I created 9 groups in Excel for each of the 9 scenarios for each of the 9 pseudo-siblings. And since there was only data for 3, I just had to copy and paste, 6 more copies or 2 more copies of each of the sibling comparisons and then label them appropriately in the group column. And this isn't going to be good enough to do the visual phasing. I'm going to have to actually create those 9 profiles. So I'm not trying to get around, having multiple profiles in DNA Painter. That's going to be necessary. However, I just want to make it easier to send this over to Australia so she can get started right away tonight and run the script and upload to GEDmatch. But we're not quite there yet because we have a couple more things to do. So let's go back into Borland Genetics. I'm going to close this file. Okay. So let's select the kit for which we've mapped our ancestors in DNA Painter. We start with Sib1 and Sib2. We use build 37 data. Okay, and now we are going to find the DNA Painter file that I called Three Siblings Demo. All right, and there they are, the 9 groups. And let's start with the first one, Sib1 and Sib2 pseudo-sibling, and extract that data. And again, this is going to get rid of the NIR portions and only leave us with the HIR and FIR portions. And we don't want the FIR portions, but that's a separate process we're going to do in a minute. Now, the extract segments tool does take a while, so in the interest of time, I am going to speed this up. Okay, so the gender for the pseudo-sibling, we don't care. Let's make it female. So reconstruct ancestor source successfully added to active resource list. Let's take a look at the resource list. And there it is, Sib1 and Sib2 pseudo-sibling. And it is 31%. And every pair of siblings is going to be a little different because of the randomness of DNA inheritance. So back to main menu. And let's, we can take a look at those segments if we want. We can view the segments. Just takes a second here to render the visualization. And there we go. And that's about 2/3 coverage of the mono kit, just a little under. Okay, so return to the main menu, and let's go into Manage Scripts again, because I'm not going to do this 8 more times for you. Instead, we're just going to edit the script. So let's stop recording the script, and let's take a look at it. Part 4. All right, so look at that. It has something new, but let's create a comment here, and then we extract, then we use extract segments tool to eliminate NIR regions. Okay, so we don't just want to do it one time. Oh no. 2, 3, 4, 5, 6, 7, 8, 9 times. And we'll just change the parameters. So we've got Sib1 and Sib2. This refers to what the which pseudo-sibling file it is that we created originally. The full pseudo-sibling files without the NIR removed. So then we have sibling 1x sibling 2, sibling 2 x sibling 1, sibling 1 and sibling 3, sibling 1 x sibling 3, sibling 3, oops, x sibling 1, sibling 2 and sibling 3, sibling 2 x sibling 3, sibling 3 x sibling 2. Okay, and we're not totally done because we've got to adjust the other parameters for each one too. The DNA file is going to be the same for all of them because we packaged all 9 pseudo-sibling maps into that 3 siblings demo in DNA Painter. Build 37 is the same for all, but now here we go, sibling 1 and sibling 2 pseudo-sibling. Okay, well that's right for the first one, but for the second one we're going to want to do sibling 1 x sibling 2, and then we're going to want sibling 2 x sibling 1, and then we're going to want sibling 1 and sibling 3, sibling 1 x sibling 3, sibling 3 x sibling 1, and you know it's got to match the first parameter I did, of course. And then sibling 2 and sibling 3, and then we want sibling 2 x sibling 3, and the final permutation is sibling 3 x sibling 2. And let's just replace the script 4. Let's just take a look, make sure it actually did replace it before we get carried away here. And there we go. So we've got a nice script here. We're going to eliminate the FIR segments next, but First, let's send what we have off to Australia because um, we don't need Borland genetics to do that, to remove the FIR. We're going to do that in DNA Painter, and we can do that while our assistant is, or our gracious donor is uploading, running the script on her computer and uploading the files to GEDmatch Genesis, uploading the 9 files that this will create. Oh, one last thing. Before I do that, I want to go back to the main menu, manage DNA resources, and well, I want to have it be part of the script too. So I'm going to turn on that script recorder one more time, manage script, start recording, and I'm going to call it Project 3 Siblings Part 5. Continue, back to the main menu, manage resources. I want to save the resource list. I want to make sure that when it's done, it saves a copy on the computer. Okay, so that's, we're going to call it Project 3 Siblings. Okay. Now back to the main menu, and we will shut off the script manager for real. Stop recording scripts. And maybe insert the final comment there. Open it up. Scroll down a bit. There we go. Save a copy of the complete resource list to the data library. Now, something interesting here, because notice the parameter that we put for input for save resource list is just the name of the resource list. So it doesn't actually, it's dynamic in terms of what data is in the data in the resource list that which is going to save. So that I only have some of these output kits in my resource list, but by the time it gets to running this script on her computer, it's going to actually have all of the output files in there. So that what would happen when I hit save resource list now is going to be different than what happens when she hits save resource list. It's going to save all the resources that the script creates, not just the ones that I created while creating the script. Okay, so now I'm back in DNA Painter, and I've already fast forwarded a little bit here, and I sent over the information to Australia so she can get started uploading to GEDmatch, but I don't need anything new on GEDmatch to continue on. And what I sent her was the script file and the modified DNA Painter CSV file that I expanded beyond the three comparisons and made it the 9 pseudo-siblings. So she's got that. I realize I forgot something, actually. I forgot to include the X chromosome, and it's too late now. But what we would have done is when we painted the new match, and I had it frozen before, for privacy, I only painted in the autosomal because I only ran the GEDmatch one-to-one compare autosomal, and I should have pasted at the end the X chromosome also, but I didn't. And if I scroll down here, because I've created this profile, this is one of the 9 profiles that I'm going to use when I actually do the visual phasing. You'll see there's no data on the X, and I apologize for that, but there's no need to do that. You should also include the X on this. There's a lot of people have misgivings about the X chromosome, and I think a lot of that's unfounded, but that's an issue for a different day. Okay, so let's go back to GEDmatch, and I am going to build 37 still, but this time I'm going to reduce the threshold to 3 centimorgans, and I'm going to show only full segments, FIR segments. And people are going to say 3 centimorgans. Okay, that's insane. That's going to be, let in a lot of fake segments, right? And because the 7 centimorgans is like the standard. Well, first of all, with phase data, I would say 5 centimorgans is the standard, or at least the standard I use. I think that a 5 centimorgan phase data is about as likely to be accurate as a 7 centimorgan unphased segment. But I'm not lowering it to 3 to let in more data. I'm not trying to prove that this person is a cousin, and I'm not trying to force or a relative. I'm not trying to force a relative match. Rather, what I'm doing here is I'm actually being extra cautious because we're going to remove the FIR. And if there's any FIR in it, it's not going to properly reconstruct over those. So if something even might be an FIR, if it's only 3 centimorgans long, but it looks like it's an FIR segment, we're going to kill it. So we're actually being over conservative by reducing the threshold, contrary to what most people think about reducing thresholds. This is an example where a lower threshold is good. Now you don't want to carry away, but I think 3 is appropriate for this. So let's submit, and here we go. This is the FIR regions. Copy. Then I'm going to go into the DNA painter, paint a new match. Paste, and now here at the end of 22 is where I would have gone back into GEDmatch and done the X comparison, but too late for that. So here we don't want to exclude segments. We want to make sure we don't exclude the, the 3 centimorgan segments, otherwise it defeats the purpose of lowering the threshold, right? Okay, so save the match, and we've got to give the ancestor a name, and we're going to call it do not touch FIR. And when we do the visual phasing, let's make it stand out. Let's use white or maybe black. Choose, and this is a mono data, so we don't care what side of whether it's on your mother or father's side. We only have 1 copy of the chromosome here. Save match, and there we go. Now we've got all the FIR regions marked as do not touch, and we're going to visual phase around them. This has been a really long episode, and we just finished step 2. We still got steps 3, 4, and 5 to go, and my roommates have been sleeping for quite a while. I don't want to disturb them, so I'm going to call it quits for tonight. I'm getting a little sleepy too. So this is to be continued. So part 3 of this 3-part series is going to be maybe part 3A and part 3B, I guess. And hopefully not part 3C, but I think I can cover the rest of the material in an hour, even in great depth. Okay, well, I hope you understand what we got here. You see the NIR is not shaded at all because we actually eliminated that when we, in the kits themselves, when we created them. The HIR is going to be, I guess I'm colorblind, but I guess you'd call that like a green maybe. And the the FIR segments are going to be black. So all we care about is the parts that look green here. And this is for SIB1 and SIB2. We're just going to do this 8 more times. And I am going to do it 8 more times. I'm just not going to do it on the camera because there's no need to torture you through that. If you want to do this for yourself, you can. And I say torture, but it's actually pretty easy. But it's not worth extending the video by another 40 minutes unnecessarily. So until next time, to be continued.